Okay, welcome back to math class. You may remember dilations from previous chapters when we talked about enlargements and reductions. Enlargement and reduction. A dilation enlarges or reduces a figure proportionally, but what we're doing today, instead of just enlarging something where it stands, is we're enlarging it with respect to a center point by a specific scale factor. So it's an enlargement or it's a reduction around a center point by a certain scale factor. So what's going to happen is you're going to have, they'll say, here's your center point, here's me a triangle, and then they're going to say, I want you to enlarge this triangle by a scale factor of 2. So what I'm going to do is I'm going to take my ruler and I'm going to draw a line from my center point to the point in the shape. I'm going to make sure that this line extends past my shape. And I'm going to do this for all 3. There's A, B, and now here's C. Oops. Okay, so I have these 3 lines from my center point through each of these points. I may need to extend them here in a bit. Now what I'm going to do is, because my scale factor is 2, I'm going to measure the distance from my center point to B. It's about 7.5 inches away. And then I'm going to, so we'll call this D, right? The length of D to B, that didn't really look like a D. D to B equals 7.5 inches. So my D to my B prime, after my scale factor, is going to be 2, my scale factor, times 7.5, which is going to give us 15. So I'm going to take my I'm going to go along my same line here, and I'm going to go 15 inches this time. So this is a 12-inch line long, 12-inch long line so far. So let me go 3 more inches, and that's going to be where my new B goes, my B prime. I'm going to do that to the same thing to the other point. So my A is 4.5 inches. So DA equals 4.5 inches. So D to A prime will equal 2 times 4.5, which is 9. So I'm going to measure on the same line to 9. And that is where my A prime will be. I'm going to do the same thing with C. C is 10 inches. So DC equals 10 inches. DC prime will equal 2 times 10 inches will equal 20 inches. So let me measure. C to there is 12. Make sure you keep your line lined up with your other line. Okay, there's our new C prime. All right, now that we've got our new points, we'll connect all of our dots. And I'll have this new triangle that I know is 2 times the size of our original triangle. I've taken our original triangle and enlarged it by a scale factor of 2. Now this is all on paper, so what do I do if it's in the coordinate plane? You guys have some experience enlarging shapes or reducing them in the coordinate plane. So let's just practice one. Let me get our x's and y's. They're going to be point A at 0, 6. Point B at 2, 1, and point C at 3, 4. Okay, so now we're going to raise it to a scale factor of 1/2. So since that's a fraction, since our scale factor is a fraction, we know that this is going to be a reduction. So our final shape should look smaller than our original shape. So what we're going to do when we have our scale factor and we have our points is I'm going to take our points and just multiply each of them by 1/2. So our x and our y are going to become 1/2 x, 1/2 y. So it's going to be 1/2 0, 1/2 6, 1/2 times 2, 1/2 times 1, 1/2 times 3, 1/2 times 4. And we'll solve that straight through and get 1/2 times 0 is 0, 1/2 times 6 is 3, 1/2 times 2 is just 1, 1/2 times 1 is 1/2. 1/2 times 3 is 3/2, and 1/2 times 4 is 2. So this is our A prime, our B prime, and our C prime. Now all that's left to do is graph your original triangle, then graph your new triangle, plot the points, and then connect them. It should, when you graph them, it should look like that one is half the size of this one, and that's how you'll know that you did it right. And that's all I have for you today.